Hi everyone, welcome to today's video. In this video, we're going to cover a special type of a smart contract called a factory smart contract. So as the name suggests, a factory smart contract is basically a factory for smart contracts. Like a real factory, it lets you create multiple instances of the same contract. Where is it useful? What are its utilities and purposes? And how you can make money using a factory smart contract? We'll talk about that in the upcoming section. Before we dive into the factory contract, I'm going to talk about some optimizations that we can do to our contract. As you can see here, we have this require statement. What this statement is basically doing is that when this function is called, it checks if the person calling this contract, the message.sender who is assigned to the caller variable, if this caller has already casted a vote, they will be present in this mapping, and so they won't be able to cast this vote anymore. This line will basically make the code exit, and all the code below it will not run. And you can see that in this line, all the other variables, so updated number of votes and existing number of votes, don't get used. Their only utility starts after the require statement has passed. So let's see what happens when I try to call this function twice. I am going to start with a test with a question. Let's say what is 4 plus 4, and I'm only going to add one option, which is 8. So this is only for testing, and I'm going to deploy this contract. And when I try to cast my vote, right, for the first time, it succeeds. But when I try to call it again, it fails with this error. So the code did not execute, as you can see here, right? This error statement gets called here. Let me see if I can zoom into this. Yeah. As you can see, this error statement gets called here, and this require statement returns this error, and code doesn't run beyond it. Let me zoom out again. Yeah. So what that means is that this updated number of votes variable and this existing number of votes variable are unnecessarily declared. So the optimization that I'm going to do is that I am going to move this line up. So I'm going to comment it from here, and I'm going to put it at the very top. And instead of using caller, what I'll do is I'll directly use message.sender. And so basically, as you can see, existing votes is basically just the casted votes mapping, right? So what I'll do is I'll just write casted votes and check for message.sender. Now this line is doing the exact same thing, but the advantage here is that this line will be called at the very beginning of this function, which means that if this require statement, this message.sender is already present in casted votes, it will error out, and all these variables will not be declared. This is called an early bailout. This is a very common practice in software programming. It allows you to free up some memory by not declaring unnecessary variables. So if there is a statement in which you think that the function can exit out early, you try to put it at the top. So now what I'll do is I'll just try to delete this instance, deploy this contract again with our same question, what is 4 plus 4, and I'll only provide one option, which is 8, and deploy it. Let's see what happens. I should be allowed to cast my first vote, which is there, and the second vote does not go through because it says you can only cast once. So it is behaving in the exact same way, but internally in my second call, less memory is being used. Great. I'm also going to remove this comment because already taken care of, because and yep, the rest looks good. So let's move on. I'm going to create another file, and I'm going to call it CodeApp Factory. Yeah. Great. I'll also, just copy these first two lines from our previous contract because this is generic. I'll start writing the contract as Pole Dap Factory, and yep, the curly braces. And I'll also create a variable here, which I'll call, which will be public, and let's call it Pole Dap instance. Now the type of this instance is going to be Pole. Okay, before I actually do that, I should also import this contract that we are going to create the factory for. So since we are creating a factory for our polling dApp, I'm just going to import it since it's in the same file. So // means the same directory, and yeah, so yeah. Okay, now that we have imported it, I'm going to create an instance which is a poll dApp instance, and the variable type for this is going to be poll dApp. The reason that I'm keeping its variable type here, as you can see, is poll dApp, because it's going to store the address of the contract that we create. So, going back to the fact that this is going to be a factory contract, it is going to create instances of poll dApp, and we are going to store the instance that we create in our poll dApp variable. So, okay, let's start writing a function. I will create a function called create poll dApp instance, which is going to be our factory function. It will take in a string memory as a question and another very input as the options. So, okay, then it's going to be public, and it will return a variable of type poll dApp. Great. Let's go here, and so now to create a new instance of our poll dApp, which we have imported here, we are going to use the keyword new. So in our poll dApp instance variable that we are going to store new poll dApp, and new poll dApp will basically create a new instance of our poll dApp that we have imported. We are going to pass the question to it and our options to it. So when this function is called, it will take in a question, it will take in options, and it will call this poll dApp as a variable, or as a class, and it will pass question and options to its constructor. Then I'm just going to return the poll dApp instance. So we have just written one function which is taking in the same parameters as the poll dApp factory, the poll dApp contract, and it is just returning this poll dApp instance. So let's compile and see what this is actually doing. So this is already selected. I'm just going to compile it again. I'll delete old instances, and yeah, I'll just go and deploy it. So I need to select poll dApp factory from here. I will deploy it, and in this instance, as you can see, it's allowing me to use this function. So I'm going to pass some variables to it. So again, I'll pass let's say what is 3 plus 7, and to make it more interesting, I'll pass in two options. One is 10 and the other is Harry Potter. Let's call this function, and the query went through. Let's look at what our variable poll dApp instance has right now. So as you can see, let me zoom in a little bit here. As you can see, we have gotten an address in our poll dApp instance. Now this address is where this new poll dApp is actually stored. And how do we check that? For that also, so Remix comes with this utility where I'm just going to copy this address and paste it here. Then I'm going to select my polled app and I'm going to click on add address. So let me minimize this and I'll click on add address, and as you can see, it shows polled app at 0x568, which is, the address which the new instance is deployed to. Let's quickly go through it once. In this, let's try to get our question, and as you can see, it returns our 3 plus 7. Let me walk through this activity again. I'm going to keep this instance, but I'm going to go to my factory again, and instead of 3 plus 7, let's make it what is 5 plus 7, and our first option will be 12, and let's just keep Harry Potter. So before calling this function, I am still getting my old address, which is 0x568. But when I create polled app again and I get polled app instance, now I get a different address. Now I'm again going to take so what this basically means is that a new instance of my polled app, this function that this contract that we have imported, is created at this address. In Ethereum, all contracts are deployed at a specific address, and the latest instance that we have created is available at 9b9. So I'm going to copy it, and what I'll do is I'll again deploy my polled app at this address. So polled app is already selected. Sometimes this button doesn't, so there's a bug in Remix, which is why this button doesn't get enabled every time. I'm going to copy it again, and yeah, okay, this time it worked at address. And yeah, as you can see, now I have two instances of the polled app. So one is 0x568 and one is 0x9b9. I'll open 9b9 and I'll check my question, and as you can see, I am getting 5 plus 7 here. At the first instance, I'm still getting 3 plus 7. I can actually cast votes on them separately as well. So let's get the vote count first. In my first, let's see, for 0th option, right now we have 0 votes. I'll cast my vote for the 0th option and try again. As you can see, there is 1. I'll try to cast again and I'm erroring out. I can go to my second instance now, but there I will be allowed to cast a vote, and I can check the vote count for the 0th option. So as you can see, I have used this factory to create two instances of the same contract, but they are deployed at both different addresses. Now this is a very powerful thing, because what this allows you to do is that you can expose your contract as an API to people outside of the, outside your organization via a factory. So if you give them a factory and you can provide them access, we will learn more about access control in future videos. But by, adding access control, you can let people create instances of your dApp. So I have created this polled app and I've created a factory. Now I can tell people, hey, go ahead and use my factory to create as many polling dApps that you want. What this allows you to do is that it basically allows you to abstract away your code and let other people play with it. They can create their own dApps using your dApp without having to write code again. And that is a very powerful thing. Now there is a slight problem with our implementation. If people start to use our factory, we have no way of tracking how many instances of our polled app actually exist. We do have this polled app instance variable, but as you can see, it only stores the value of the latest contract which was deployed. So this address only corresponds to the latest instance. If I were to deploy another instance of this, and I get this, the last address is lost now. I have no way of knowing that these two instances also exist. So what I'll do is I'll slightly, let me zoom out again. Yeah. What I'll do is I'll slightly modify my implementation, and what I'll do is, instead of keeping polled app instance as a variable, as a single variable, I'll keep it as an array. And in an array, I'm just going to return, a string from memory. And here I'm just going to return done. Okay, Looks like there is some problem with this. I think I'm supposed to write that. So we are getting another warning. Let's see what it says. It says type contract polled app is not implicitly convertible to expected type contract polled app array. Basically, now that polled app is an array, this polled app instance is actually an array. We can't directly assign to it. So let's modify our code a little bit, and instead of directly creating this, I'm just going to create another variable here. I will just call it temp, which will basically be the new instance. So let's call it polled app. It will take question and it will take options, and its type is going to be, let's keep it as an address. Actually no, this will have to be of type polled app. And now instead of assigning to polled app instance, we are going to push to it. So in this, we are just going to pass it the temp variable. Now all our warnings are gone. So let's recap what we have done here. Earlier, polled app instance was basically storing one value. Now what we have done is we have converted it into an array, and every time a new instance is created, we store that instance's address in our polled app instance array. I'm going to clear out our old implementation contracts and let's see what happens when we deploy it. So I'll go to the factory, I'll deploy it again. And yeah, let's add another question. What is 0 plus, actually let's make it more interesting. What is the answer to life, universe, and everything? If you're a sci-fi fan, you will know what the right answer is, and the right answer is 42. I'll also add another option which is I do not know. Let's deploy this. And looks like our contract is deployed. And let's check out the instance where it is stored. Now, since our polled app, is an array, it will have to basically be called with the index. So since this is our first instance that we have just created, the address of our the contract that we have deployed using the factory should be stored at the 0th value. And as you can see, the address is here. Let me just go up. I will select polled app and I will erase the old address. I will paste in the new one and deploy it all. Now here I have the polled app which is deployed at this address, and let's check out what the question here is. And as expected, the question is correct. Let's also create another instance. Let's see. I'm just going to erase this question and I'm just going to say what is 40 plus 2. I'll keep the same options and I'll deploy again. So let me minimize this. Yeah, let's click on deploy and looks like it went through. Now on 0, I will still have the old instance, but on 1, I have the new instance. So let's also check out this. Again, we'll go up, clear out the address, paste it here. And yeah, now we have 2 instances. Hopefully their question values will be different. Here it is still our original question. And now here is our new question. So again, we can go back to our, factory and on 0. So if we now remove our, both the instances, we can retrieve them because we know that, on 0, we have this value. On 1, we have this value. And on 2, we don't have any values because it errored out. The reason is because our array only has 2 values. And that's it. So we have created a factory contract here, which you can use to generate multiple instances of a contract. And in future videos, we will also see how this can be used to provide software as a service on Ethereum. basically you can actually charge people to use your factory. So if you have a app that you think can make you money, you can actually create a factory for it. And right now anybody can call our factory, but you can actually add access control to your factory, and you can add some payment terms to your factory, so that if somebody wants to create an instance of your DApp, they can actually pay you some Ethereum to, get that privilege. So stick around, we will cover that in our upcoming videos, and thanks for joining. I'll see you guys in the next video. Bye bye.